After we were talking yesterday, I was playing around on a prototype in my backyard, and I cracked. It's not bad at all, but I cracked my forehead on a solar panel. I was like, yeah, this is appropriate. Like, this is the story of my life, banging my head against solar panels. It's 2 o'clock. We'll go ahead and get started. The top of the hour here. I am lucky enough to be joined by GoSun's board member, Peter Lilienthal. Peter brings a huge wealth of knowledge and experience in the realm of off-grid design. As many of you might know, GoSun, we build solar-powered appliances for recreation and resilience, and so much of that applies in the off-grid realm. So I'm just delighted to have Peter, and we're just going to connect over the next half hour, and then we're going to really look for you guys to jump in and ask your questions. Add them to the chat. But thank you so much, Peter, for joining. GoSun for joining in this call. And let's hope over the next half hour, people know a little bit more about solar, about you and your experience, and about where all of this is going. So, Peter, I wanted to ask, like, originally, let's just go right into the deep stuff. You've been in solar for pretty much, and off grid and renewable energy for the entirety of your career. Like, what got that all started? Is there an origin story there? Like, what inspired you?
Well, it was a combination of things. I just recorded a video with that answer, basically just answering that question. It's about an 8-minute video for Johnny Weiss's, who founded Solar Energy International. It's an
Mm,
international training organization.
he's a dear
Uh,
friend.
yeah, he's a great guy, and Solar Energy International is having a legacy project for him, solar for developing countries. So. Um, it wasn't a single thing. I studied international studies as an undergrad. I been a big fan of decentralization for a long time. I recommend the book Small is Beautiful. It's a little old now, but it
Yeah,
kind of changed my
Schumacher. Nice. Oh, me too.
yeah, that and I was always sort of an energy nerd, but when I got out of grad school, I went to work for the National Renewable Energy Lab, and I got sort of sick of doing like standard utility modeling for big utilities. And but so the most important thing was at the Earth Summit in Rio in 1992, um, President Bush Sr. went down there and he said, "We're going to help developing countries use renewable energy." And of course, in '92, it's pretty early days. And he didn't know what he was suggesting. He wasn't suggesting anything specific. So he came back so NREL was tasked with, okay, figure out what to do. And a guy here at Larry Flowers, who's retired now, but he created the Village Power Program, which and through all through the '90s, it was just a great program. And they needed a model. And it was a great application of what I just learned in grad school about optimization and modeling. And so that's why I built Homer back starting in like early '90s. It's gone through a lot of iterations. But that Earth Summit in Rio was what kicked off Village Power at NREL, and that was early days. I just noticed Richard Hansen joined. I'm so glad he joined. So he's saying, well, no, I was there before then. Okay. And there were a few people like Richard Hansen who were around in or before then, but not very many.
And how
And
cool, man! That was a lot of great material there. We gonna unpack that one. Um, and how interesting that Bush Senior had this thought. I mean, that to me, like, here we go, like 30 years later, China had that same thought. We're gonna use renewable energy to help developing countries develop. I mean, is that not like what's happened in the last 20 years or 15 years? Big
well,
time.
I mean, a lot of people like Richard, but now there's more and more people have been plugging away at this for a long time.
Yeah.
And in the '90s, I'd say the technology really wasn't ready. People might disagree, but it was at NREL was a research program, so that makes sense. But when the price of photovoltaics dropped a few years ago. I mean, it's dropped sort of continuously, but it broke through a threshold a few years ago where suddenly this makes a lot of sense. Um, and uh, and really, there's no place that's burning diesel 24/7 that should be doing that. That should still be doing that. And I've been on this kick that it feels like a lonely argument I'm making, but I really feel strongly about this. The developing country utilities should stop extending the grid. except in a few exceptions, like there's a big mine somewhere, or there, but solar mini grids and off-grid systems, individual systems, uh, can provide high quality power now, and utilities in most developing countries do not provide high quality power. It's unreliable. The voltage just varies, blows out equipment, and but mini grids and individual systems can do that now. Um, and so, I mean, there's a great World Bank report just about a year ago on some mini grids that are being built where the grid already exists, and people are choosing, saying, "No, no, I know I got the grid, but it doesn't work very well. So I'm going to join this mini grid because they can provide better power." So now I've gotten sort of excited about that's for cooking even, which is, I mean, it used to be you couldn't think about cooking with PV since PV was too expensive. But now that's not true anymore, and the batteries are good enough, and that breaks open a huge market. Off-grid world is really taking off just as I'm retiring, but not
Well,
fully
it's cool.
retired.
We're not going to let you retire entirely. That's
Yeah,
right. And we know I can see the passion in what you have to share. Like you still, you see so many solutions, and it sounds like the economics of solar has really kind of disruptive and sort of changed your mind in the current, moving forward. But I want to talk a little bit about, keep going back because I think your past is so amazing and interesting. And we met, I think, when you had started as Green Island Energy. It was
yeah,
right around when you left NREL.
yeah,
Um,
yeah.
and and you like right around that same time, I was using Ret Screen as it was a Canadian based modeling tool because I was doing a bunch of off grid and solar thermal and stuff. But but we started to use Homer, which you developed, and I want to talk about Homer and um, like all the elements of power generation that you built into that was sort of mind blowing for me. Can you go into that a little bit more and kind of how I guess you knew so much about generators and revolutionary energy, and at the time everything was sort of a genverter, like you had to have revolving power to make things work. How does Homer still apply today as well, if you could?
Well, first thing is being at NREL made a big difference because I'm sort of a math nerd, I'm an economist. I have a PhD in engineering, but I'm more of an economist. It doesn't, and I, but being around people who, there was a solar expert, there was a wind expert, there were battery experts. We hired a diesel expert. There was a little bit of a cultural difference there between us, but I thought it was really useful to have somebody like that. I really liked having him as part of the team, because you have to understand the technologies too. You can't just be a math modeler. You have to understand the technologies. On the other hand, a lot of the people who are really deep in the science and technology of, say, how does a photovoltaic cell work, they don't think about economics at all. So being around a huge diversity of experts made a huge difference. And I gave kudos to Bush Sr. for kicking this off. Bush Jr. killed the Village Power Program. So the early 2000s were really tough, and that's why I ended up licensing it out of the lab and creating a private company. There was a period there in between where I was losing support from the Department of Energy and and I did to some extent get some private companies to pay for keeping Homer going.
Well,
It's a journey, but it's been fun. It's been really good.
oh yeah, no, for sure. And the amount of people that have been able to use Homer and gain valuable insights from it has got to be, tens of thousands. And I understand is that a lot of that work was in developing countries, did you find that most of the users and software subscribers were, in islands
Yeah, yeah,
and
absolutely.
austere?
Absolutely. Either they themselves were on island in developing countries or on islands, or they were part of a development organization, or research organization that was focusing on that. That was so. I think there's three markets that I always focused on. The first one was energy access in developing countries. Um, but the other one that I is our islands, and not just geographic islands. There's like 200 villages in Alaska that are just running 24/7. Well, in the past, we're running 24/7 on diesel because they're way too far to they're isolated villages. They're electrical islands, not necessarily. Some of them are geographic islands, but that's what made it fascinating. The diversity, not just the diversity of geography, system design, but cultural diversity too was so I love that. So those are the two original markets. And then after Sandy, Hurricane Sandy was a real eye opener to the whole industry that diesel generator, it's great for an occasional short outage if you're a hospital or whatever, or for any kind of occasional short outage. But for the kind of thing that happened in Sandy, where people were without power for weeks, it was a regional outage. There aren't enough fuel trucks to keep the diesel generators going, and the roads might be messed up. And if you want real resilience, you got to have solar on site. That's just the only way to have true resilience. Diesels are pretty efficient at full load and very, very inefficient at part load. Um, and solar is sort of the other way around. It'll work continuously, but you're not going to put in a huge one. You probably don't have space for a huge one. So you got to prioritize your loads. You got to think about load management, but you have to think about what loads are curtailable, what loads are deferrable was a term we coined at Homer. Um, for something that like pumping water. You got to do it, but you've got a lot of flexibility about when you do it. Um, Charging cars is another one, is the huge one. A factoid, I hope I have this, I'm sure I'm approximately right. The power of the US light duty vehicle fleet, everybody's car in the country, compared to the power of the utility industry, just the horsepowers, kilowatts and horsepowers. The U.S. light duty vehicle fleet is literally an order of magnitude 10x greater than the power of the whole utility industry. That's
Yeah, I
mind blowing.
remember seeing. I remember something that was over 30x one time when I
Oh,
saw that
really?
statistic from Amory Levins or something. And yeah, it's like, and that maybe that's something a good transition to. You think about the electric car, and all of a sudden that energy is so much more dispatchable. It's already electric. And copper doesn't care
Sure.
which way the electrons are moving, and so I'm very excited myself in the whole vehicle to load or vehicle to grid. And I would think that, utilities and a lot of the friends you've made in the utilities and regulatory markets would be also very interested in that.
Oh
Have you
yeah,
had
they're
experience
doing
there?
it. They're doing it in Europe. Starting to do it. When I first heard about that, I was still at NREL, and they had a hybrid vehicle program, and they contacted me because they wanted to do some modeling, and I got kind of into it, and there was a professor at the University of Delaware, Willett Kempton, who had been plugging this idea. I don't know when he started, maybe in late 90s or maybe early 2000s. And another guy, Stephen Latondra, who's still plugging this idea of vehicle to grid. And everyone's going, and people were so skeptical at first. Um, and I was thinking, oh, this is a great idea. But the vehicle people were like, oh, no, no, nobody's going to want to do that because, I mean, you got to compensate people. And there's all kinds of regulatory issues uh, associated with it, but those are solvable issues
Right.
theoretically. I mean, they are or absolutely should be solvable issues. And suddenly you don't have to worry about intermittency. You don't have to worry about spinning reserve. You don't have to worry about frequency regulation. You don't have to worry about any of those ancillary services. If you've got enough storage that's controllable, and storage is more controllable than traditional utility resources.
It's safe to say that really the technology is not the problem. Like we can do anything with technology, and really the problems are largely human, cultural, leadership oriented, regulatory oriented. That's kind of what I'm taking out of that. Uh, so often we're in our own way for reasons of private interests or it's just the way things go, and if it's inconvenient, for any party, the consumer, the utility, then it's much less likely to succeed. And a lot of this stuff is slightly inconvenient, particularly to the utility. They're used to centralized power production, and they just want to have consumers. And all of a sudden, the consumers are producers. Whoa, whoa, wait a minute here.
It's huge about how hesitant people are to change. Now, some people love change, but most people just want to keep doing what they've been doing and the utility industry and on top of that human nature aspect, the regulatory structure makes it hard to change because you got to get regulators to approve, and then they have to have hearings, proceedings, and people come in and argue, and a lot of people come in with a bunch of misinformation and argue, and they got to sort all that out, and it takes forever, and the regulatory process is inherently slow.
Solar, in my experience, I've been involved in the industry for about 25 years. I know you've got even more than that. Who's counting? But I don't think I ever anticipated the cost of the panels and the energy storage, the lithium, to be this low cost. I really attribute China to a lot of that. This sort of, to me, like the fifth great industrial revolution is this sort of renewable energy boom and electric vehicles, electrification. If I ran a Homer model today at the current economics, do you think it would make any room for diesel or propane or?
What sort of depends. I actually haven't given up on reciprocating generators, whether they're diesel or propane or whatever, as backup. It just makes life easier in a way. And the trick is you're not going to use it very much. If you're using it very much, something's wrong. This project I did for EarthSpark International, they're the ones building mini grids in Haiti, and because Haiti is such a mess, they can't get diesel fuel delivered. They're just like, okay, we give up. These have to be 100% renewable because the diesel is just not going to get to the village. Period. So, but then we looked at using, and what if we added cooking, made the system big enough for cooking, which is a pretty big load, certainly in terms of power, less so in terms of energy, but in terms of power, it's a big load. So size it for that. And then how many days a year would we have to tell people, okay, look, it was cloudy yesterday, or it's going to be cloudy today. You can't cook today. You got to go back to wood or charcoal. For how many days a year would they have to do that? All the other loads became 100% reliable. But if you curtailed the cooking for 9 days a year, that was it.
Wow.
So that blew my mind. So load management, if you're not diesel means you don't have to manage your loads. You can just burn fuel. It's just kind of this stupid, simple way to do it, right? But if you manage, but you can get away without a diesel, but you're going to have to manage your loads a little bit, but maybe not that much, really. Depends what you got. But if you have an electric car and you're charging the electric car, that's a really easily managed load.
Yeah, and I've been kind of holding out on this whole vehicle to load, vehicle to home. You got a 75 kilowatt hours on wheels, and you've got these giant conductors coming in and out of the battery. Like, I to your point around the equation with EarthSpark, you only needed it for 9 days of the year. Um, I might only need to borrow power from my car for 9 hours of the year. I mean, I live in a pretty reliable grid, but I'm surprised I can't access that energy, particularly right now on a Tesla. I understand maybe that the Cybertruck has
Well, and
a
the Ford
pass through.
F-150 has, but it's not. I don't know the technical details of it, like how much power you can get and whatnot. And you can always get
Mhm.
12 volts off a cigarette lighter, but that's
Yeah.
really not.
Right. Well,
There's so much
that
more
goes into
potential.
the. Yeah, I got to plug GoSun with that one. GoSun has been building. Peter has been talking a lot today about mini grids, and we build nano grids, right? We actually have a product called the GoSun grid, and a lot of it runs on 12 volt. I mean, the 12-volt cord, a 12-volt plug is on every car, truck, boat, or RV made since the 1950s. So we went ahead and leaned into that. And now with that same cord, you can cook dinner, you can brew coffee, you can heat water for your shower, you can run your refrigerator. And we build all these small lithium ion batteries that have that 12-volt socket on them. so that you can, use it to run the fan, run the heated blanket, and kind of, GoSun's mission has been much smaller than a lot of the stuff we're talking about. It's like using solar and battery for really small applications for, when you are in the backyard off grid, when you have gone camping, when you're on the boat, the bass fishing boat, not, all the toys that we help you fuel are $100,000 less and less, that they're not the yachts that are already comfort machines. GoSun is all about kind of the easy off grid and austere that starts, as soon as you leave your house. So there's my little plug for the moment. I do see a couple questions coming in. First, Jim had asked, is your old software found at homerenergy.com, Peter?
Yes, yeah, I'm pretty sure it is.
Yeah.
UL bought it, Underwriters Laboratory. They're not called UL. The, Underwriters Laboratory has been around since the 1890s doing testing, inspection, certification. That's their bread and butter. But they have this, I don't know if you call it a subsidiary, probably UL Solutions, doing software and advisory. And they're the ones that bought Homer, and they're still supporting it and distributing it. And actually, Powering Health Homer Energy is still up and running, and that's a super simple. I think it's a little too simple, but we created this web app that runs Homer in the background and tells you what you need to power a little rural health clinic.
And so if people wanted to use Homer right now, would they go to think homerenergy.com and figure out clicking around on that website? Because it used to be like free, right? It used to be available through NREL, or I don't remember
Well, a
how I
long
was
time ago.
licensed. Hmm.
Yeah, yeah. Okay, so the very first Homer was ran on a Unix workstation. It used specialized optimization software. It was strictly internal at NREL. There was only me and one other person that could run it. Then Tom Lambert converted it to a C++, and we put it up on the web, and now people downloaded it. And yeah, at NREL it was free. But then NREL couldn't really support it, so we commercialized it, which meant we had to start charging for it, and so yeah, we did, but it really took off, and we supported it. Um, After we sold the company to UL, they increased the price pretty dramatically. I talked them down a little bit. They wanted to increase the price even more. Uh, so so you go to homerenergy.com. I'm hoping that you still have a free trial. I'm not sure about that. I'm really not involved with UL anymore.
Oh,
Um,
cool. No problem. I mean, thanks for, taking a stab at that. We do have a couple questions that are coming in, and the first one, somebody asked, Jim asked, what happens when you oversize your battery or oversize your PV? Won't the battery be a better backup? Question from Jim.
Well, that is a way to have a backup is to oversize systems. Absolutely. It's going to cost more, right? Um, so it may not be the economically optimal way to do it, but there's if you don't if you but it allows you to avoid having a diesel generator, right? And there's reasons to want to do that. So depends how you define better, but it certainly works, and you just need a lot more, as you say, oversized. You need a lot more batteries, a lot more PV. So the diesel generator, there's a trade-off. That's why optimization software is so useful, because it allows you to really investigate the trade-offs, like how much how many batteries you need to reduce your fuel by how much, that's and it just
Yeah.
depends on so many things. People really focus on the solar resource. They go, well, we're in a sunny place or we're in a cloudy place. That is actually the least of the issues. It's more about what your load looks like, how erratic is it, how variable is it, and that, and how big are we talking? Um, that's actually, and if you're grid connected, what's the utility tariff and regulations? Those are all way more important than the solar resource. My sister's doing.
And I definitely want to piggyback on that. Oversizing things, I've learned a lot in life, is generally a good idea. Yes, it costs more upfront, but usually it's a small incremental increase because you're already buying the thing. And this is true on a lot of our purchases, with like water pumps or inverters, or, you generally, you benefit by not running the thing at its max capacity. Because when you run it hard at its max capacity, it's going to have a shorter life. versus if you run it at sort of 50% of its output, for
Well, except
example.
that's not true for diesels though. Diesels
Hmm.
really don't like to run at part load, and
Right.
they end up running at part load a lot, and it's just inefficient. You get condensation in the exhaust, you get carbon buildup in the cylinders, you get I don't even I'm
Yeah.
getting on the edge of my knowledge here, but there's all kinds of problems in addition to just being fuel inefficient. Running diesels at low loads
Diesel
is
generators.
bad.
Yeah. Yeah, well, good. This is great stuff. Keeping on. Jason asks a great question. Peter, any thoughts regarding moving forward with GoSun?
Oh, I
A
love
little.
open-ended questions.
It's very,
Um, I'm not sure what exactly he wants me to talk about, but when we haven't talked about your solar car charger, which is a really exciting product. So you put this thing on the roof and it's got its own battery, and so it charges while you're driving around, and then you can plug it in. But when you park, you can open it up, and if you park it in the sun, you get like 20 or 30 miles a day of charge. That might be all you need. I mean, we have a little electric vehicle, and we rarely drive it more than 20 or 30 miles, and just bopping around town here. And then I was telling friends of mine, so I live in Colorado. A lot of people love to camp here. There's a lot of really remote places you can get to camping in the mountains. Um, but I would never do that with my little electric car but just it's too far. You have to go. You have to go uphill and blah blah blah. But suddenly this makes it possible because okay, you go camping and you set this thing up and it's sitting there charging, and you can get home. It makes it makes the electric vehicles no longer limited. Like we just use ours around town, which is 90% of our driving. So it's 90. We love our little electric car, but now it's unlimited. It has so much potential, I think.
yeah, and this is just version 1.0 of driving on sunshine. It's only going to get better and more powerful from here on out. And in that camping situation, I've actually done this in my vehicle where I can actually run almost all the interior appliances on GoSun. Like I got my GoSun cooler, my oven, my coffee maker. So my camping equipment is all electric and all super efficient, and they can be run on sunshine just as well. And while the car is parked and I'm at the campsite, I've got it covered with the array, and the vehicle itself is staying much cooler. I've slept in my Tesla Model Y, which is quite comfortable, and so it has sort of these extra benefits, these ancillary side benefits that are notable and worth sharing here. But Don has asked, with respect to cradle sustainability and kind of our ethos or design ethos, and I'll go ahead and answer this one, Don. Basically, GoSun is very, very adamant about don't throw it away. When you look at the classic triangle, reduce, reuse, recycle, people don't often realize that that's a hierarchy. Reduce consumption, reuse the things that you have, and if you really can't use them anymore, please try to recycle them. I'm not a great big believer in plastic recycling or plastic in general. Metal recycling by all means, yes, absolutely. But again, the things before that are what's more important. So GoSun is all about reducing the use of ice or single-use utensils or alkaline batteries. We're all about reusing our products. So anytime that we have a returned product, or we ask a customer to send it back to us, we'll fix these. We have a whole zone of our workshop here where we're refurbing old products. And then every couple times a year, we'll have an open box sale or a refurbished sale. So it's a huge, important part of my ethos. Um, and I really appreciate the work of Cradle Cradle as a design parameter. We try to avoid as much of things that aren't recyclable as we can. And we are kind of wrapping this up. We are kind of nearing the end here, and we have a comment from Mick here. He's a $5,000 investor, wondering where the EV charger is. So Mick, we are about to head into production on that product. So we're just kind of like dotting our I's, crossing our T's. We have a bunch of working prototypes, and we're kind of ironing out all of our purchasing and supply chain relations with our manufacturing partners. I'll be spending some time again over with them this summer, and then we'll get into productions at the end of the summer for shipment at the end of the year ish. So our goal right now is Q4. We don't have any super specific details about when your EV solar charger will ship. But hopefully that's all been apparent, and we'll be sending out like monthly emails, monthly updates to everybody, whether you're a pre-sale purchaser or if you're an investor at the 5K level. Thank you, Mick. Is there anything, Peter, you want to, where do you see solar energy trends headed? I mean, we've talked a lot today about how low cost things are. You want to kind of wrap us up in the big picture here? It seems like anything's possible with solar.
Yeah, no, I think the utility world is going to change in a big way with solar and batteries are just going to change everything. The here in the U.S., and I see a note from someone in Africa, but I think most of the people on the call are here in the U.S. Things have, um, we're gone into reverse in a bad way, which I'm very confident. I get teased for being too optimistic, but that this is a temporary problem. I'm very optimistic that we're not going to be stupid for very long, um, and return to what the rest of the world is doing, is just going all full gang on solar. In fact, I mean, utility industry is saying, hey, we need power now. Solar and wind are the only way we're going to get power quickly and at a reasonable price. So I'm still very, very bullish on solar and batteries completely changing the utility industry in ways that we maybe can't totally predict because the regulatory process is a little. That's the thing I worry the most about is can the regulate, we have 50 state utility commissions and all kinds of local. I heard that 1/3 of the counties are putting in restrictions on solar. So there's some regulatory issues that are my biggest worry, frankly. Um, but you can't beat solar at the price of it, and you can't beat the flexibility of batteries and the versatility of them. And that's the future, regardless of what some idiot politicians think.
All right. So you have heard that here first, folks. And I
Not
also,
first. I'm sure if you haven't heard that before, I'm not saying anything
and
new.
you're living in a hole. Yeah. Yeah. No, I mean, folks, if you don't know that like we are living in the solar energy revolution, we are in the midst of like solar has gotten so inexpensive that there's no counter argument that can be made on an economic basis. Those arguments are all 20 years old or maybe a decade old. They're certainly not relevant in 2025. And the technology is so unbelievably capable. We've talked a lot about it in the last 45 minutes. It's really it's the issues are generally human. And I'll say it again. Peter called them all solvable issues, but I'll share in your optimism. Thank you, Peter. Thank you so much for staying like hopeful and true and right about what tomorrow will bring. Um, Pardon the pun around the sun, but it is like it we are entering the solar energy era, and a lot of the kind of status quo and powers that be don't really want you to know that in the States, but China is doing it. I keep referencing them as the unicorn in the space, but they're basically the leaders, and it's a shame that we're not giving them more competition because we really should, or more collective collaboration. So thank you guys all so much for joining us. Thank you, Richard. Thank you, Douglas. Thanks so much, Peter. I'm really grateful to have you all. Do want to remind you guys to take a look at GoSun. We are in the midst of an equity crowdfund raise that can be discovered at startengine.com. And use more sun as the slogan says, or as the back of Peter's shirt says, portable power for the people. Yeah, baby.